start recording? Okay, it looks like it did. Ooh, it's recording. Okay, let me get this out of the way real quick. Oh, wait, I want to pull that back up because I want to see if you can all see what I'm about to show you. So let's make sure the video comes around here. So this is my laptop in the closet, and if you see right here, it is building an AI model at 1.5 billion parameters using our new Rust library. So this isn't using Python or PyTorch or anything like that. It's just running in our Rust bare metal library. So you can see over here, kinda, camera doesn't go as far, but you can see right here the processor is working, the GPU is barely working, and this is doing the autoencoder. So it's only doing one layer right now. Later, when it kicks on all the full layers, the CPU and the GPU, they work together to process everything. So that is essentially what I'm coming to talk to you about today. So you can see my desktop, which is very unusual. The first thing that I want to cover today, oh yeah, I'm John Reagan with Boredbrains Consortium and Ulshe AI, which is our product group. Boredbrains is for really working with the full theory as a whole. So what you can see here right now is that I have my Google Play console up. I'm going to refresh it real quick, and then you guys will be able to see that we are 6 days away right now from launching our Android app. So the Easy Bake, Ulshe Easy Bake AI Forge V1, which will allow you to build potentially up to 1 billion plus parameter models if you have enough RAM on the device. So really excited about that. That doesn't even use the stuff I'm talking to you about today. Those models are based off of regular transformers with a modified attention head, and then using knowledge graphs in order to reduce the overall load. So they work really well. Here's my investor pitch, you might say, but that's not what I want to show you. What I want to show you is this right here. So this doesn't look like much, but we are training basically a 4 billion parameter model, right? Based off of, pull up the code, based off of the parameters. And we're running a short build process here just to test everything. You can see that the recon, this is a loss. This drops the way it should. Our anxiety starts at half and it drops the way it should, and our learning rate adjusts accordingly based off the outputs. So this trends all the way through. This is not optimized either. So once I ironically optimize the optimizer for this library, it will run at a lot faster pace. So what am I doing here that's so amazing? Well, first of all, I'm building a multi-billion parameter model on the machine sitting here next to me. But even more so, I'm building it right now using no VRAM. Well, to be fair, it's like 250 megabytes of VRAM. But you'll see the GPU is pegged right now, GPU 1. Now let me show you something really, really neat. GPU 1 is actually building 2 AI models for a total parameter count. Oh, this one's gotten a little ways away already. For a total parameter count of 3.5 billion, or sorry, 4.5 billion parameters. So we can see this one I dropped to 4096. It's still doing batch 15. We have some basics for Xavier compensation limits. But yeah, this one is training. I did 100. And again, even seeing these loss numbers, you have to understand it's not optimized. It's a very raw optimizer. So once I have this optimized, both the loss and the time are going to drop significantly. So over here on this much larger model where we're seeing times as high as 44,000 seconds, which is about 12 hours, that will drop by, let's say, a factor of 100. So it'll be basically 440 seconds for these longer, larger data sets on this larger model. But again, more amazingly, I'm doing this without any VRAM. Like you can see right here, look behind the camera. Right here, we're using 31 gigs of system RAM to build this 4 billion parameter model. And right below it, we're using 3.9 gigs. It sometimes goes up to 4.1. But I think I adjusted this one down up to be 3.9 with the new updates I did for the calculations. Don't worry about that. Um, is it's building this half billion parameter, 500 million parameter model on the GPU. These will be done. The smaller one looks like, where are we at? So we're on phase 3. So this one will probably be done in the next 24 to 48 hours. This one has about 20 days left on it with this one. So, but if you try to do this today with using Python and PyTorch and building a multi-billion parameter model, you would have to get a data center card. You would have to get huge amounts of RAM. So what I've done is I've basically leveraged the processors at their most base level for what they're the best at. So currently the CPU is handling arithmetic and coordination between the processing of the weights and the forward and back propagations. The GPU doing some probing and some testing and stuff. It looks like the GPUs handle the forward pass a lot better, whereas the backward pass calculations are handled a lot better by the CPU. So we reduced all this to straight integer math. So there are no floats. Our AIs built on this will not hallucinate. They will have a range of understanding, but they don't work in the same, how should I put it, quasi non-deterministic way that the decimals and floating points tend to work. So it actually becomes both a model of determinism and a model of floating point capability, which is where we get the creativity that comes from finding those statistical anomalies in AI models. So this is really exciting to me because this basically levels it. Like VRAM is 40 to 60% of the heat, 40 to 60% of the power consumption, and the cost has gone so far up. So this basically breaks this whole Ramageddon concept, right? That we're facing right now, this whole situation. Let me get over to show you what I did here. So, actually, let me just, I was going over a demo and stuff for somebody, tech memo. Anyway, so in here, we go ahead and in this Pascal-Chimera, you can see that if we get those things out, you can see the batch size, you can see the total layers are 30. You can see here where I've adjusted this model down. This is the 500 million. The 4 billion parameter model dimensional size is 11,520. So it does come in at about 4 billion parameters with 30 layers. So we have 12 syntax, 10 semantic, and 8 reasoning layers. These are all built off our Chimera engine basis that we have and how that works. We've also established our own mict tensor setup, our Dojo, our CUDA access, which this essentially just treats the GPU as a math coprocessor. We also have our chat interface, which allows us to basically chat with the AI, test out how it's doing. And also our reinforcement dojo, which allows you to take, scroll back up here somewhere. There we go. It allows you to take the flashcard deck, like right here, basically loading one of the data sets as a flashcard deck and loading one of the models that are made during the initial training cycle, because at each phase it saves a model and we can test those and see how they're doing, how they did, how they're doing basically, and if there's adjustments we need to make and maybe start over because it doesn't take us that long to build these models, or if we need to just basically make some changes or adjustments during that specific phase, because each phase has its own lesson set and each lesson set is being different and slightly structured differently, does different things with the AI models. So I'm actually kind of surprised because this one has got really high levels of anxiety right now. Like its anxiety is gone way up, but it's a good thing because it's gone up on syntax and linguistics, which is, it's not a huge lesson set, but it's something that it needs to think about. And then we hit logic and we have its anxiety. It's working really hard right now, but it's, the constructive loss is going down. So its learning rate is pegged. I mean, its learning rate is super pegged. For lack of a better term, I'm drilling this AI model really hard on the gradients, just as testing. I'm just trying it out. So, but this new Rust library I made, as you can see here, it's all self-contained. It allows us, I'm working on setting the variables and such, so you can basically set all your hyperparameters as well as the model architecture, because we do have currently 13 plus various AI architectures to select from and build. And this just totally democratizes the aspect of being or even making an AI model. So you don't need multi-billion, $1 million data centers and stuff. As a matter of fact, these building these in this way shows that the inference is going to be a lot less. And the practice I've done so far on the models I've made for inference, it is considerably less. We're seeing without KV caching yet, which is my next thing, we're already seeing 20 to 30-second response times on 20 or 30 tokens. So not huge in the response, but we're definitely seeing the shakeup that you should see. We're definitely seeing the composition of response and the overall thought process in the processing based off of the size of the question. So smaller questions get smaller thinking. Larger questions get more thinking. It's basically that simple. So, oh, that's interesting. I would check on this learning rate. I might be pushing it too hard. I'm freaking it out. Someone might be trained really well. We'll see. Um, so yeah, so basically we're able to do that, establish the foundational model, and then begin training, deeper training, and building on top of that. Additionally, this Rust library is so flexible in the way that it works that I'm able to take somebody else's open weight model now, convert it, and run it within my system as well. So I can actually, PolyMorphOS originally was designed to run our AIs, but given that I can now convert their model weights, if they're open weight, to our platform system, we'll be able to use those as well, and not just use them, but we'll be able to continue their training. We'll be able to basically unlock the neuroplasticity that these other AI labs lock away. So we embrace it, we use it, right? We find the faults and we find ways that they become an advantage versus a disadvantage. So I will not be releasing this publicly. This is not something that you're just going to get free access to on GitHub or anything. As a matter of fact, just as a reminder, my software is on GitHub and open source, so you can view the code and make sure I'm not stealing your information and make sure that I am doing what I say I'm doing. It is not there for free. All right, if you are using the code, if you are making money using the code or using those concepts and ideas that I've put in there, the licensing agreement is very, very clear. All right, that you are accepting the license agreement just by its usage. So, and those numbers are also very clear, and the conditions are very clear. There's no ambiguity in my license agreement. So don't think you're going to get around that, because, you know, if I find it, I'll just charge you for it. So, but for personal use, if you're just sitting at home, you're like, I want to make AI at home, go ahead. If, you know, you're in a research lab and you're like, this looks interesting, I want to play with it, you know, see how it works, go ahead. You know, it's designed so that everybody can begin producing their own AI, and it's not this mystery system that people have to, I don't know, have some multi-million-dollar job at some open lab somewhere for you to consider them, you know, decent or possibly able to do it. It's really something anyone can do. You just have to get the understanding and knowledge under your belt. So that's it for now. I do have some updates on polymorph. Let me actually pull up. We'll go into polymorph real quick, and then I will just run it so you guys can get a view on that. See if it boots or drops. Kimu's funny like that. It's a funny little system. So here, I've already got it set up so I can auth USB. And we're authorized, right? And so now I've got some details to work out, but you get this settings page here, and we can move over here. And right now what I'm working out using the settings page in Polymorph are the window UI elements. So essentially when you make your WASM app for our PolyMorphOS, this will translate then across into the Gaussian Splat engine, and then this will basically show you, will allow you to use the windowing elements. Right there you see I clicked the light theme button, and so this I got to clean up a little bit more too. It's still dirty. And in doing that, this light theme, you can actually see the Gaussian splats better that we're using as the background, right? Can't see the mouse because it's white, but hey. So, and this is actually going to be adjusted and changed. There's actually quite a bit of UI work I need to do here. So instead of using one big splat like this that bleeds out, it's actually going to be 4 of them that overlap each other in a flower pattern, allowing for a much better cohesive window. Working on the menuing system, a couple other things, just UI components basically right now. A lot of the main structure, the back-end engineering stuff I've got pretty well set up. Like I don't have it plugged in. Oh, I guess I do, but I'm using it to show you right here. I wonder if it would do it. A file already exists. So we can, what is it? UEC init. Yeah, so we can actually do that. You can see it inits down there. The command failed because right now I'm running this. It's already in use, but also Kimu has some issues with raw data flows. They're a little too much for it. So it's actually something I'm working out right now is getting it off or out of Kimu and then putting it onto hardware so that I can develop more directly in the hardware. But otherwise it doesn't work too bad. I mean, click on it, we get the windowing coming. It's a little slow right now with everything I have going on. And if I click this, we get our orbing, right? Which basically puts it off into the background. Now, later on, this is going to work in a different way, and you'll understand because it'll be a 3D background that we have access to, right? Oh, I minimized that one. That was a mistake. So anyway, so you get the idea. It's coming along. I gotta change that cursor color. That's funny. It's like it's gone, man. It's like snow blind. Anyway. So that's it for that. That's it for the updates. Essentially we just blasted everybody's build environment out the door. You don't need VRAM, you don't need giant data centers. You just need to think about how this stuff works and what you have available and how to make it work with that. And so by doing that, we've achieved some pretty significant efficiencies and some pretty amazing structures and stuff that you just really couldn't do any other way.